and now we will see the planes. Okay, and here for the planes we adapt. See, from the starting onwards we have been adopting some new methods. Okay, so how to represent the direction? By knowing 2 points, and we will go by our actual procedure. What is that procedure? X minus x1 divided by x2 minus x1 equal to y minus y1 by y2 minus y1. That is the actual procedure. But here actually that is for the sometimes we represent even for a plane also, that equation. Okay, but here we are adapting some new terminologies. So here this is a Miller indices. Okay, so how to represent the plane by using the Miller indices, and that is a HKL. Okay, by using the 3 coordinates we will represent the entire plane. That is the idea here. That is the crystalline plane. See, this is only for these crystals. We developed only for the crystals. Why we are developing all these? Why? I already mentioned we need to see on which plane for example, if you want to see the number of atoms that are laying on any particular direction, then you need to have a plane. Okay, how you represent the plane? You need to have some language. So that is what we are trying to develop. Some language we are developing for the plane. And see here, the parallel planes have identical indices as like in the previous case for the directions. Okay, so how to find out this? You write down this procedure. After that I will explain. Okay, so first you find the intercept by planes on the axis. Okay, for example, if you take the cube, and in the cube we have a 3 coordinate axis x, y, z, and you take any plane and try to find out the intercept of that particular plane of on the x-axis, y-axis, and then z-axis. Okay, then those intercepts are nothing but RST. Okay, you find out the first intercept made by the particular plane, and here the Miller indices is nothing but those reciprocal of those intercept. You might be wondering why we need to do reciprocal. Why can't we use it directly? Why? Because if any plane is parallel to any axis, then what is the intercept there? If a plane whichever I have chosen is parallel to the x-axis, then what is the value of intercept there? The value of intercept there in that case is infinity. It is not finite, but it is infinite. Okay, then how you represent there as infinity? So to avoid such complications, we will go for the reciprocal. Okay, that is what I have written here. So here HKL is nothing but reciprocal of those intercept. Okay, reciprocal of those intercept. And see here I have given some of the general ideas here. For example, if a plane is parallel to any axis, then its intercept is infinity. And if a plane passes through the origin, then how to find out in that case? Okay, why? Because if a plane is passing through the origin, then it is lying along the x-axis, and sometimes it may be for example, if you take xy plane itself, then it is passing through the x-axis and then y-axis, and then the intercept on the z-axis also 0. Okay, then in that case how to find an intercept? Or if it is passing through the origin, that means the intercept at x, y, z on x, y, z is 0. Okay, why? Because it is a 0 distance from the x, y, and then z. Then if I do inverse, then how what is the value? 1 by 0, then it will become infinity. Our whole concept of making reciprocal is to avoid the infinity, but again you are getting the infinity there. Okay, so to avoid such a situation, you remember this point. You may not find in some of the books, even in Callister also they didn't mention this, they overlooked it. Okay, so no, actually it's in Callister it is there. In some of the Indian textbooks they have overlooked. Okay, sorry, Callister is the standard book. So here you need to observe that whenever the plane is passing through the horizon, then other new plane, see these are 2 points, another new plane, you need to construct another new plane by translating that which is exactly parallel to the original one. You can do that. Otherwise you can simply change the origin, okay, to the new position. You choose new origin at the corner of another unit cell, okay. Either of these two, you can avoid the situation where the reciprocal will become infinity, okay. So by remembering this, you can go ahead and find a Miller indices, okay. This is an easy concept. So what is the thing? First of all, you try to find out the the intercept made by the particular plane onto the coordinate axis, and then reciprocal of those values are nothing but a Miller indices, okay. That is as simple as that. And here there are two important points that I mentioned here. What is that? Whenever any plane is not touching but parallel to any coordinate axis, then the intercept made by that is infinity. Why? Because we assume that that particular plane is meeting the coordinate axis at infinity distance, okay. And then whenever it is passing through the origin, then you need to avoid such situation by two methods. What is that? Either by translating that plane to the some other distance, okay. Otherwise you will change the origin to the corner point of some other unit cell, okay. Now we will see some of the examples for this, okay. So the classic example I will take here is like our cube is here. Always the cube is ready made here. So I will erase this, okay. Here I will take a cube, so this is the cube, and this is the origin I have chosen. So this is the origin, and this is the x-axis, this is the y-axis, and this is the z-axis, okay. I will mark it as A, B, C, D, E, F, and then G, and this is the origin, okay. So here, for example, I try to write for as many planes as possible from the diagram. First I will take the ABCD plane, okay, ABCD plane. And what are the Miller indices for this? Indices, okay. So what are the Miller? We will represent with the simple bracket. For the direction we use the square bracket, okay. This is a ABCD, and this ABCD is a, see, XY is the horizontal plane, and YZ is the vertical plane, and XZ is again perpendicular to the vertical and the horizontal. This is a side plane, okay. And here ABCD is parallel to the vertical plane. Otherwise you need to see in terms of coordinate axis. See, ABCD is this plane, front plane, and where it is touching the x-axis, it is touching the x-axis. Let's say the cube is having a unit, dimension 1, okay. So it is touching at a distance of A, which is having a 1, okay. So first you find out the coordinate axis of this. This coordinate axis is like a 1, and then where it is touching the y-axis, see, this is the y-axis, and if I extend this plane like this, it may touch at the infinity. So that is why it is infinity. And where exactly it is touching the z-axis, it is also infinity. In other words, the ABCD plane is parallel to the y and as well as the z-axis. So whenever it is parallel to the any axis, then the intercept is infinity here, okay. So I need to take reciprocal of this. So here it is a 1 by 1 and a 1 by infinity, and then 1 by infinity. Then it will become 1, 0, 0. Okay, so whenever I write 1 0 0, that means it is a ABCD. Okay, now I will see take OGFE. OGFE. See, what is the OGFE? That is again the plane which is parallel to the ABCD but on the back side of the cube. Okay, so for this, it is going through the origin. This plane is going through the origin. Okay, we will take that after some time. Okay, so for the time being I'm neglecting the plane which is going through the origin. Now I will take the plane BGFC. Then that is parallel to the x. So parallel to the x means it is a 1 by infinity. Why? Because its intercept is infinity and it is cutting the x-axis, y-axis at 1, so 1 by 1, and then it is parallel to the z-axis, so again it is 1 by infinity. Then it will become 0 1 0. This is the value. Okay, now I will take one more plane which is not passing through the origin, but I will take ABEF. Okay, if I connect this like this, okay, this is the plane. This is the plane I want to take. So I'm starting here, going here. This is inclined plane. Okay, this is the inclined plane like this. What is that? ABFE. ABFE. If it is for example, if it is like a BCC crystal structure, then on this particular plane we would that body inside one more atom is there, no? So that body atom will be there on this particular plane. Okay, so we need to find out this. What is that? This is important, so that's why I'm writing in red color ABFE. Okay, so what is the intercept made by this on the x-axis? It is making an intercept of 1, so 1 by 1, and then how much intercept it is making on y-axis, because it is parallel to the y-axis, then it is making infinity, so this is 1 by infinity, and it is also touching the z-axis at 1, so 1 by 1, so its value is 1 0 1. This is the plane. Okay, like that we can find out as many as possible, for each and everything we can find out that. Okay, that is the meaning of finding out here. And coming to the plane passing through the origin. Okay, for example, I will take two cases, like how to find out the plane passing through the origin. In the same cube, for example, this is the y and this is the x and this is the z. Okay, here let's say I have a plane like this. I have a plane like this. This plane is passing through the origin. This is the origin. This plane is passing through the origin like this. Okay, so here if I try to find out the intercept, then it will become 0 0 0, and if I try to find out the Miller indices, then it will become 1 by 0 1 by 0 1 by 0. That means it is infinity infinity infinity. So it is not possible to find out this. So in that case, what I told, either you shift the origin or you shift the this plane by translating it. See, this plane is coinciding on the xy plane. This is nothing but a xy plane. This is an xy plane. That means it is perpendicular to z plane. Okay, so I will move this along the z axis in a such a way that it is remains parallel to the xy and perpendicular to z plane. Okay, so I shifted here, the same plane I shifted here like this. Okay, I shifted either See, this is an again origin. I can shift upward like this, or I can shift downward like this. Okay, in either way I can do this. I can shift downward also like this. So by doing this, okay, what is happening here? For example, I shifted one unit above and 1 unit below. Then the Miller indices here in this one, HKL equal to the intercept. For example, if I take this plane 1, the intercept made by the plane 1 on the x-axis is infinity. Why? Because it is parallel to the x-axis, so 1 by infinity, and then on y-axis it is again 1 by infinity, and then on z-axis it is making, let's say, 1. Okay, its value is 0, 0, 1. Okay, this is how we need to find out. For example, here if I want to find out the plane ABOG, then how I need to find out? I need to translate this, either below or up. Okay, I told like instead of this I can change the origin also. Okay, I can change the origin to the another crystal. So for example, here this is a simple cube. Okay, so here this is O A B C D E F G. So here I want to find out the plane that is joining O to F like this, and then A to C. Okay, this is the plane I want to find out. See, it is going from A to C, C to F, and F to O. This is the plane I want to find out. Okay, but this plane is passing through the origin. Okay, when it is passing through the origin, we cannot find out that. So one way of doing this is by constructing another crystal here. Okay, by constructing another crystal here, by extending this, okay, another crystal which is forming here is this. Okay, so I formed another crystal. You can see this. See, this edge is invisible, this edge is invisible, this is visible. So I constructed another crystal. Okay, just touching this. Then I shifted origin from O to the O dash here. O dash. I shifted origin to here. So here in this case, I can calculate this. Okay, how this is at a distance of 1 and this is at a distance of 2. So by knowing that, I can calculate this. Why? Because we already learned like whenever you multiply the value with any integer, then the whatever value you get is equivalent. Okay, in the same way here, by translating the origin you can find out this. For example, here in this case, let's find out. Okay, so this is parallel A. You can imagine this ACFO. Okay, I think you can imagine. See, if I draw ACFC, then it would be like this. This is the, let's say this is the ACF and then O. Okay, AOFC. Okay, so this would be like this. So this is parallel to the x-axis. So when it is parallel to the x-axis, then that is 1 by infinity, and it is cutting the y-axis at a distance of 1, because from this origin to the another crystal origin it is 1. So 1 by 1, and again if you further extend, then it will cut the z-axis in the negative direction. Okay, it will cut the z-axis at a -1. So 1 by -1. Okay, if we extend, it will cut in the downward direction. Then its value is 0, 1 and 1 bar. Okay, this is how we need to find out. This is how we need to find out this. Okay.